Here are the answers for the section 7-12 homework assignment. For question number 1, we're asked to solve this for m. So first step, we'll isolate the radical expression by adding the 8 to the other side. Now we have the square root of m is equal to 8. Now let's choose an operation that will remove the square root. And that operation is to raise to the second power. So we're going to take the left side and go to the second power, and the right side and go to the second power. When you square the square root, that produces the m. And over here we have the answer 64. Now it's important we check the answer to make sure that what we get isn't a restricted value. So the square root of 64 does make 8, and 8 minus 8 equals 0. It checks out. Number 3, on the left side of the equation, we have the radical already by itself, unlike question 1 where we first needed to move the 8 to the right. This one's ready to go. What power could you raise to in order to remove a cube root? That would be to the third power. So take the left side and raise to the third power, and the right side raise to the third power. That creates the y plus 2. And over here, this is 64. Now subtract 2 from both sides, and we have y equals 62. Now we want to check this, make sure it works. So if y was 62, we would have 62 plus 2, which is 64, and the cube root of 64 is the answer 4. Number 5. First thing, let's subtract the 6 in order to isolate the radical expression. Now the radical is alone on the left side. Now let's raise to the second power. That removes the radical, leaving the 5x plus 1. And over here, 4 to the second power is 16. Now subtract 1 from both sides, so 5x equals 15. Therefore, x equals 3. Let's check and make sure that really works in the original problem. So right up here in the original problem in black ink, 5 times 3 is 15. 15 plus 1 is 16. The square root of 16 is 4. And 4 plus 6 is 10. That checks out. Number 11, first add the 2. That gets the radical expression by itself. And now we have 32. Okay, now let's remove the square root by squaring both sides. We have b to the 5th on this side, and over here, whatever 32 squared is. With the help of a calculator, that's 1024. Now we want to remove the 5th power in order to get the b alone. To remove the 5th power, you take a 5th root. Let's find the 5th root of 1024 with the help of a calculator. If your calculator doesn't have a 5th root button, then what you're actually going to type in is 1024, then the exponent key, which is often this little arrow key, and then as an exponent, the 1/5 power. Having a 1/5 exponent is the same thing as doing a 5th root. That answer turns out to be 4. Now let's check that and make sure that really works. Back in the original problem that's in black ink, you would go 4 to the 5th power on a calculator, then do the square root of it, then minus 2 to make sure that turns out to be 30. Number 15, let's remove the square root by squaring both sides. On the left side, we get the y minus 2. On the right side, we are squaring a binomial. Square the 4, that makes 16. Now double the product of the two terms. The product of 4 and y is 4y. If you double that, it's negative 8y. Then square that last term. That makes a y squared. This is a quadratic equation because the highest degree is 2. Let's put that in standard form by getting a 0 on one of the sides. What I did was I subtracted the y and I added the 2. in order to make this side be a 0. But then I just switched both sides using the symmetric property. This expression factors as y minus 6 times y minus 3. From the first factor, we get that y equals 6. From this factor, we get that y equals 3. Now let's check those and make sure they really work in the original problem. First, let's try the 6. 6 minus 2 makes 4. And the square root of 4 would make a 2. But when you put 6 over here, we have 4 minus 6, which makes negative 2. That answer does not check out. Now let's try our answer of 3. 3 minus 2 makes 1, and the square root of 1 makes a 1. On the other side, in black ink, it was 4 minus 3, which also makes 1. So this answer works. Number 17, let's remove the square root by squaring both sides. That produces the expression that was inside the radical. And on the right side, again, we are squaring a binomial. So p squared plus 2p plus 1. Using subtraction, the p squareds will cancel away. So we have negative 3 equals 2p plus 1. Now we can subtract 1, getting negative 4 equals 2p, and then divide by 2 to get negative 2 is equal to p. Now let's check that in the original problem, which was in black ink. So you got to ignore the stuff that's in purple. So fill in negative 2 for p. Negative 2 squared makes 4. 4 minus 3 makes 1, and the square root of 1 makes a 1 on the left side. Now on the right side, when you put in negative 2 for p, we get negative 2 plus 1 makes negative 1. Those are not the same, so this answer does not work. We have to say empty set. Number 29, we can remove the cube root by raising both sides to the third power. That produces the expression that was inside the radical. And with the help of a calculator, we can figure out what 9 to the third power is. That's 729. Now we want to remove the squaring, and you do that using square root. So that creates the 5x plus 7. On the other side, we're going to have the positive and negative square root of 729. Let's use the calculator to see if the square root of 729 is an integer. It is. It makes 27. So we have 5x plus 7 is equal to positive or negative 27. Now let's subtract the 7. So we have 5x is equal to negative 7 plus or minus 27. And then we're going to divide by 5. So we have x is equal to negative 7 plus or minus 27, all divided by 5. This actually is going to make two different answers. So negative 7 plus 27 is 20, and 20 divided by 5 is 4. Now let's use the subtraction sign. Negative 7 take away 27 is negative 34, and negative 34 divided by 5 is negative 34 fifths. Now we need to check both answers into the original problem that's in black ink. Certainly a calculator would help you do that. Let's try the answer 4. 5 times 4 is 20. 20 plus 7 is 27. And now we want to go to the second power. That makes 729. And then we want the cube root of 729, which is 9. So the answer 4 checks out. Now let's try this negative answer. 5 times negative 34 fifths is negative 34. Negative 34 plus 7 is negative 27. Negative 27 raised to the second power is 729. And the cube root of 729 is 9. Both of these answers check out. Number 37, we're asked to solve this for the variable d. So first step, let's remove the cube root by cubing both sides. On the left side, it becomes r cubed. And on the right side, the cube root radical is gone, and we're left with the expression that was inside the radical. Again, we're trying to get the letter d alone. So in the next step, let's multiply both sides by 4 pi d. That will take this denominator and move it over to the left side. So we have 4 pi d times the r cubed, and that's equal to the 3w. Again, we want to get the letter d alone. All of these things are being multiplied to the d. So let's divide by them. We're going to divide by the 4, the pi, and the r cubed. That will get the d alone. So we have 3w over 4 pi r cubed. Number 39, we want to solve for the letter a. So the first thing to do is remove the square root symbol. So let's raise both sides to the second power. That makes c squared equals, and the square root symbol is now gone, so we have a squared plus b squared. Now subtract the b squared. So we have c squared minus b squared is equal to a squared. Again, we're trying to get the a alone. We have to remove that exponent. So we do square root. So we have the square root of c squared minus b squared is equal to a. For the review assignment, we're going back to page 284. In this question, we're asked to give the nature of the roots. What that means is, are the solutions going to be real numbers, imaginary numbers, or what? To figure out the nature of the roots, we use the discriminant, which is the b squared minus 4ac expression that's inside the radical in the quadratic formula. Before you find the discriminant, you have to create standard form. So the square root of 5, z squared, minus 6z plus the square root of 5 is equal to 0. Now let's figure out the value of our discriminant. This is the a, this number is the b, and this number is the c. So we have the square root, and now we want b squared. So that's negative 6 squared, that's 36. Minus 4 times the a times the c. Let's work inside the radical. We have 36 minus, and then let's look at this part here. The square root of 5 times the square root of 5 makes a regular 5, and 4 times 5 is 20. So this is equal to the square root of 16, which is just positive 4. Next up, using the chart that's on page 283, what is the nature of the roots when the discriminant is a positive number? That tells us there are 2 real roots. Next, number 12. This one here is also about determining the nature of the roots. In this problem, a is 1, b is the 8, and c is the 16. So let's use the discriminant, which is b squared minus 4ac. b squared is 64, a is 1, and c is 16. This turns out to be 0. So using the chart on page 283, when the discriminant turns out to be 0, there is 1 real root. As I was working this problem, I noticed that you don't have to use the radical symbol around the b squared minus 4ac. The discriminant is only the b squared minus 4ac. It's not the value that you get when you take the square root. So back on number 7, I really should not have had the square root symbol around there. I was only interested in what did the stuff inside the radical turn out to be, which was positive 16. Sorry, I didn't notice that earlier. Back to number 12. There's another part to this question. if you have real roots, we are asked, are they rational? So to answer this question, we're using the bottom of page 283. There's a gray box. And in that gray box, it says that an equation that has rational coefficients, and certainly having a 1 and an 8 and a 16 are rational coefficients, will have rational roots only if the discriminant is the square of a rational number. Well, our discriminant is 0. Is 0 the square of a rational number? Yes, 0 is the square of 0. So this is, yes, it has a rational root. Number 18, we have an equation that has the letter k in it. And we're asked to find values of k so that this equation turns out to have only one solution. Again, this has to do with discriminant. We want to pay attention to the b squared minus 4ac value. Right in front there is a, which is a 1. Right here is the b, which in our problem is k. And the number on the end is the c, which in ours is k minus 1. So let's figure out b squared minus 4ac. We have k squared minus 4 times a, that's a 1, times c, that's a k minus 1. Let's simplify this a little bit. We have k squared, and then 4 times 1 times k is minus 4k, and negative 4 times 1 times negative 1 is plus 4. That's our discriminant. Now, in order for our equation to have one solution, the discriminant has to equal 0. So let's just say equals 0. And now solve this for k. Hey, how about factoring method? K minus 2 times k minus 2 equals 0. So we can see that k is equal to 2. Page 255. What we were doing back on this page was solving equations. So on this one here, we need to subtract 1 from both sides. Now we have 64s to the 6th is equal to negative 1. And then divide by 64. So we have s to the 6th is equal to negative 1 over 64. And now we want to remove that power. So what root do you do to remove the 6th power? You take the 6th root on both sides. The 6th root is an even indexed root. So that's when you do plus and minus. We're used to doing plus and minus when we do square roots, but it's whenever you're taking a root that has an even index that you do plus and minus. So on the left side, we just get the s, and over here we have plus or minus the 6th root of negative 1 over 64. But notice something here. We're doing an even indexed root, and the number that we're trying to find the 6th root of is negative. You can't do that. This is empty set. Number 26, we want to solve this one for r. First step, let's simplify the 6th root of r to the 6th power. There are two possible results, positive or negative r. Again, whenever you're doing an even indexed root, that's when you have the plus minus sign. Okay, this is going to generate two different answers depending upon if we use the plus sign or the minus sign. So let's just do them separately. We have r minus positive r, and then plus 16 is equal to 0. These r's cancel, leaving 16 equal to 0, which produces an empty set. Now situation number 2, we would have r minus and then negative r plus 16 is equal to 0. r subtract negative r is 2r. And from this we see that r is equal to negative 8. Page 258. We are asked to write an equation that has this as a solution to the equation. Because this is a 5th root, we can write that x to the 5th power is equal to negative 3. There's our equation. Do you believe it? Think about how you would solve the equation. To remove the fifth power, what kind of root would you do? You would take a fifth root of both sides. You would get x equals the fifth root of negative 3. Number 14. The directions on this one are to list out all of the possible rational roots. We're not actually going to find them. We just want to know what are the possibilities. To find the possible rational roots, you make ratios. All of the factors of C divided by all of the factors of A. When I talk about C and A, I'm referring to the constant term and I'm referring to the leading coefficient. So what are the factors of negative 5? Positive and negative 1 and positive and negative 5. These are all the numbers that divide into negative 5. Now what are the factors of the leading coefficient of 1? That's positive and negative 1. So what numbers do these possibilities produce? It makes positive or negative 1 and positive or negative 5. We're not saying that these are the answers to the equation. We're saying that if the equation has rational answers, they must come from this list. Number 20 is the same directions. So the leading coefficient is 1 and the constant term is 10. So we want to do the factors of the constant term, that's plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. All of the numbers that divide into 10. And then divide them by all of the factors of the leading term, which are positive or negative 1. This combined form is really talking about plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. 8 possibilities.